If you have ever played darts, you know the worst part is counting the points. I love playing darts with my brother, but keeping score by hand or on my phone is such a pain. So I started looking for a system that could count the points automatically. I checked out Scolia, but it was too expensive for me. I also watched a few YouTube videos about AutoDarts, and honestly, all the feedback was positive. That's why I decided to try it myself. My goal was to build it for under 100 euros. And in this project, I'm going to show you exactly how to do it. Alright, now I will show you where to get the 3D files. Just go to the website, the link will be down in the video description. First, click on the download button and all the parts will appear at the bottom. We start with the main stand. We need to print this 3 times. Next is the camera cover, also 3 pieces. Then for the LED frame we need 6 pieces. After that there are connection points which attach the frame. We need 9 of these. Then comes to the part that connects the frame to the main stand. Print 3 of these. Finally there's the housing for the camera module, also 3 pieces. Now there's also an option holder you can get. This is for the gap in the frame, because in my setup some light was coming through. I decided to include it. It looks better and works perfectly. The website for this part is separate, and I will link it in the video description if you want to check it out. Here you can see how the finished 3D print should look like. This gives you a quick overview of all the parts you will need later. In the next clip I'm working on the frame parts. This includes the 6 pieces for the LED frame and the 3 connector pieces that link the frame to the main holder and the camera module. For all of these parts I'm using a M3 heat insert. In total you need 18 M3 inserts. In the video you can see how to install them. Next I'm preparing the parts for the camera modules. For these I'm using M4 inserts. You will need 6 of them in total. In the next step I will show you how to connect the frame parts. Take 2 of the LED frame pieces and 1 connector piece and screw them together using M3 screws. The screws are 6 mm long. You repeat this step until all LED frame parts are connected. In the end you will have 3 complete LED frames. Now we are putting everything together. First take one of the finished modules we built earlier. Then add the new frame holder and then another finished module. You just keep repeat this. Finished module, frame holder, finished module, until the circle is complete. Alright, now you can see the full circle assembled. Everything fits together nicely. The finished modules and the frame holders are connected. This is exactly how it should look like, before we move to the next step. So let's unpack the camera modules. They are mounted on a small circuit board and there's a little frame around them that we don't actually need. You will need to remove this frame with a side cutter. Be very carefully. Always wear safety glasses, because the pieces can fly off and could seriously injure your eyes. Once the frame is removed, screw the camera module into the housing and position it probably in the main holder. Don't feed the cable through the module yet. The correct order is first through the main holder, then into the camera module, and finally plug it in. This way everything fits together. Now we will attach the module we just assembled onto the frame. For this we are using 6 M4 screws 16 mm long. Finally we are installing the LEDs into the frame. Each side of the frame has a hole, so you can pick whichever one works best for your setup. I choose the bottom right because it fit nicely with the rest of the build. Just to note, this is a 12V LED, so make sure you connect it correctly later. Once it's in place, you can see how everything starts to come together and the frame is almost ready. Here you can see the finished module. This is the complete assembly system. Next I took a wooden board and added a felt mat with double-side tape. This step is optional. You don't have to do this way. You can also mount the system directly to a wall. I'm doing this because I want to place the system on a stand. Now in the next step I mounted the board and the AutoDarts system onto the plate. The plate is 780 mm wide and high and 60 mm thick. I mounted the dartboard in the center and measured 43 cm down from the top, and that's basically it for this step. At this point I run into another problem. There were simply too many cables and I need a clean way to organize them. To solve this I designed and 3D printed a box for all the wiring. You will find the 3D file linked in the video description below. All the cables go into this box. The 3 USB cables from the cameras and the cable from the LED. Inside the box, the LED cable is simply routed through the output. The 3 USB cables from the cameras are connected to a USB hub inside the box. From there, only one single cable goes out and connects to the computer. When I turned on the LED, some light went through the gap. I wanted to fix that, so I came up with these holders. I showed them at the very start of the video. The holders are optional, and the best part is you don't need to screw them in. You just click them onto the frame and they stay in place. So this is my project. I put it on a stand because I couldn't keep mounting it on the wall, otherwise my neighbor would get annoyed. This way the noise stays under control. Of course, you could also mount it directly on the wall if you prefer. The last step is to connect the USB cable to the computer and power the LED. To use the system, you need the AutoDarts software. I will link it in the video description below. You can just go there and download it. Once it's installed, you will need to calibrate your dashboard. If you have any questions, just write me in the comments and I will help you out. Here you can see the finished system in action. Finally, here's the cost overview. My goal was to build this for under 100 euros and I actually did it. I listed all the parts and I'm really happy with how well the system works. I have been playing with it for a few days and there were only a few small cases where it didn't count correctly. Overall, the project was a lot of fun and I would definitely recommend trying it out. Thanks for watching and feel free to check out my other videos.